Hey everyone, this is CentConnexa, aka Rich, and I am here with awesome technical leaders of XNET, and we are here collectively today to drop some knowledge on you about what makes XNET different from other DY projects and explain some of the weird internals about what makes a mobile network different from a data network. And so with me today, I have Igor. Say hi, Igor.
Hey everyone.
Igor is our lead genius on all things MNO and deep telco stuff. And then we have our amazing operations lead, Miguel, who is building out our back end. Say hi, Miguel.
Hey, folks. All good.
And we also have Alex here. Say hi, Alex.
Hey Al.
Alex is our amazing radio technology and deployment operations lead. And by the way, he's the one who's making sure all of your XNET orders actually get delivered to you so that you can join our network. And of course, hey, I'm Rich. I'm our fearless leader on this project. And the purpose of all of this is that, again, we're doing something a little bit different as XNET than some other DY projects. Our network is different, for example, than, say, Helium, that's been building a really great data network. And similarly, from Pollen, another really great 4G, 5G data network. We're building a mobile network, which is a different beast. So we're here to explain some of those differences to you. And to ultimately to invite your questions. So, of course, this is a video. We're not interactive right now, but we hope that you will have questions and come back to us in our Discord. One of the really top-level things, if you take away nothing else from this discussion, is that there are fundamental qualitative differences between an LTE or 4G or 5G data network and a mobile network. In fact, these things have almost kind of come from different sort of evolutionary ecosystems. And to have a full-featured network, you have to kind of combine both of these things. But the data network part is actually, in some ways, the smallest, the simplest, the easiest part of this. But for sort of business strategic reasons and also for functionality reasons, the mobile network part, providing a full suite of mobile network services, is actually super important. And here's the thing. If you're following other DWAY projects, many of them have said, well, maybe someday in the future, we're going to have these like major roaming deals with big tier one mobile operators, say AT&T, T-Mobile, whatever. We are actually saying we're going to have those deals really, really soon. And the reason we can do this is because we're actually building the kind of network they want to interact with. And the network does not have to be big. It's about the quality of the network, if you will, not the scale. But the second piece of information that's really important is that this is not going to be a small network. We can start small, but we're going to get really, really big. Our goal isn't simply like a few thousand nodes or tens of thousands of nodes or 100,000 nodes. Our goal is actually millions of nodes just here in the US and many millions more worldwide. And so with that, I'm going to kind of hand the mic off to Alex, who's going to moderate the rest of this.
Thanks, Rich. So yeah, lots of interesting differences that we've noticed in XNET. Let's kick off with the cluster strategy. So that appears to be different and unique in the DY space. Tell me a little bit about why this cluster strategy of deployments.
If you could imagine you're AT&T, right? And you have kind of patchwork coverage here in the US, which AT&T does. And you want to kind of fill in those gaps. What you would love to do is have some nice, imagine like some new ink blot of coverage that will cover some big region on the map that you can rely on. So what we're doing at XNET is we're trying to build these high value, contiguous, all-in-one piece chunks of network coverage, which then we can say, hey, AT&T or T-Mobile or Verizon or whoever wants to use this, roam onto this. And then your network gaps will be filled in. But there's a little bit more to that. I'm going to hand it over to Igor, who can tell us why contiguous coverage is actually really important for performance here.
Yeah, and as a user, once you get access you really want to not have patchy access, so that when you move around, that your service continues working in good shape, right? So that you don't lose any capabilities, or you don't lose service temporarily, or get any kind of degradation or anything like that. So it's really important that the coverage is continued, so that whenever you move around, you don't have a patchy service, that the service works. And really, it's about making sure that the value of the network is not just in terms of providing coverage in some places, but good coverage across several places. And the best way to achieve that is by creating clusters, so that we focus on an area and make really good service in that area. And then we move on into a different cluster to create another great service in a different area. We don't need to do this in series. We actually doing this in parallel, but we are motivating the activation or the creation of these clusters to make sure that the service is as good as possible from day one.
Excellent. Question on the monetization. Is there any value in building out the network in this cluster format?
Well, I'll take that. Yes, there is. This is not something that like XNET is pioneering. In fact, there are lots of businesses that do this. They will go and build coverage. Typically, this is in an indoor facility. It's called DAS, Distributed Antenna Array. They'll go into a building and they'll light it up with 4 or 5G, right? And then they will say, hey, anybody who wants to use this, we have this great continuous chunk of coverage that you can just roam onto. And by the way, it'll still say T-Mobile or AT&T or whatever your service is. When you go onto this, you'll just get great service. Whereas before, if you walked into this building, your coverage would die, right? Now, it turns out that's worth a lot. If you can actually provide exactly the same experience to a mobile customer when they go into a building or when they move into a region, and maintain that everywhere in that region, then the tier 1 mobile operators will pay top dollar for that. And we're talking about like, dollar a gigabyte type rates, which is really awesome. If all you can do is provide data service there in very congested markets where we need, or AT&T needs data offload, they may pay like 10 cents a gigabyte for the data. But being able to provide a seamless experience of where a customer of one of these mobile operators moves into a space and they can just do everything through that network they're roaming onto, that's worth a whole lot. That's why we're prioritizing this kind of clustered coverage approach, because that means that we can monetize this in a way that is much higher value than if we'd had a more diffuse network.
Excellent. All right. Hey, I'd love to get into some of the fun technical stuff. This is the stuff that I like. Igor, can you talk a little bit about what actually goes behind the scenes in building a data network? How do you make those architecture decisions? And what are some of the big pieces in order to get a functioning data network up and going?
The most essential thing, obviously, if we think about layers, is one of them is the coverage layer, right? So like we're discussing, providing the ability for people to access the network. And access is provided through radio towers, and by providing that coverage and making sure that each radio tower has a specific function in an area, right, in its own radio area. And then the next thing is about making sure that these radios and access is orchestrated in a way that each radio knows how to interact with the next radio or the other radio. And this is really important. So if you don't have that, basically each radio is almost like a separate network. So this is quite specific to each case, and it has to be done in continuum. So it's not something that you set up once and then there you go. You actually have to continuously monitor the parameters and the performance of each radio and make sure that you adjust that because it's a very dynamic ecosystem. And for you to be able to orchestrate and to actually manage that in real time, you need a really, really capable management system, which does that throughout the whole network, because it needs to be cognizant of all the network itself to be able to parameterize that correctly, because one radio will have a neighbor or maybe more neighbors, and that neighbor will have another neighbor, and so on and so forth. So all of them need to be properly orchestrated between them. And so we have the coverage, and then we have that management layer, and then we have the functionality, let's say, layer, and that's about providing data services, that's providing about voice services, and whole bunch of mobile capabilities that are actually the service itself on top of that coverage, because the coverage provides you access, but then the service is provided by specific functionality.
Right.
And
but now, Igor, it
Sorry.
sounds like you're getting into like the MNO side of things, the mobile network side of things, not just the data side of things. So
That's
I
correct.
want to jump in and say, hey, you've talked about what's necessary to have a really functional, contiguous data coverage, handoffs between nodes and all of that, making a great experience. But I think one of the things that XNET is doing really differently is building this true mobile network. So what does that look like on top of all this?
Oh, so it's actually quite complex. So as I mentioned, there's a bunch of functionalities that are basically almost, you can think of it from people working on different type of projects as an application, right? So an application that provides data, another application that provides voice, another application provides messaging and registration, data registration, and so on and so forth. And all of these applications, they need to be functionally compatible with a wide range of devices and between themselves, obviously. But more importantly, they need to know how to operate also with other networks. So, this is where the roaming side of things gets in. And it's not sufficient to have a data service and then a pipe into a partner network to provide roaming. Actually, there's a whole ecosystem that needs to be built around that, not only in terms of the functionality itself and the whole technical part, but also there's a lot of business interactions and business interfaces that need to be established, not only between people, but also between the different networks so that they can coordinate in each other, because actually these are very complex systems and different systems, because every network has their own set of systems that they need to know how to interact with each other. And building an ecosystem that is able to expose our network to others in a standard way, so that actually thousands of networks can interact with each other, is something that is quite complex and needs to be built on top of just, let's say, the data functionality and the coverage and everything else.
Cool. Pulling on some of the threads of some of those tools and those apps and those interconnects, can you talk briefly about some of them, like the OSS, the BSS, the HLR, and just talk about sort of some of those big blocks?
Yeah. So you may say that you have the radio layer, and then there's the core network. And the core network is where you have all the network functions, right? So the provided data service, the voice service, and so on and so forth. And some people refer to that as NSS, network subsystems. And then you have the OSS, the operating subsystems. And the operation subsystems is what monitors the network, what provides the whole configuration and upgrades and everything to the network. So it's like, let's say, a meta layer that manages, operates the whole core network and the radio itself. And then you have what some people call BSS, business support systems. And the business support system is about the systems that support more kind of the enterprise itself in terms of charging and customer interaction and partner interaction and these kind of things. And these radio core network operations and business systems, they're all very different in their nature, and they all need to be created, as I mentioned, in a unique ecosystem, so that they are all aware of each other, compatible with each other, and not only internally, but then again, so that they can be exposed externally, so that we can interact with our partner networks and create the roaming environment.
Yeah, and just following up on that, two things. So for me to jump in, there's been a lot of talk on various DY forums about the network core, and a lot of people are talking about Magma, and of course, we have some thoughts on how Magma may not be up to the challenge here. So can you briefly speak to the network core and how that supports various of these functions or doesn't support that?
Yeah, so Magma is actually a great project. So it really helps individuals or university students or other companies to build a data network relatively easily. But it doesn't support. It does support, but the way that we have evaluated, we have found much better ways to build this ecosystem that we have discussed about. And Magma definitely doesn't provide a whole core network itself, does not have much about or anything about the business support systems. It doesn't have also a lot of things or most of the things of the operations support systems, the OSS part. So it has a role to play, but it's a very specific role, and we have found much better alternatives from our point of view that would help us not only support the network today, but the network in the future, something that is much more modular, something that is much more scalable in different ways than Magma is.
All right. Another difference that XNET brings is voice service. So tell us a little bit about why that's important and how challenging it is to basically get real voice operating on a network.
It is actually very, very important. So most people think that cellular voice is going away, but if you actually pay attention to the market, it's quite the contrary, in the sense that even new devices that are coming up in the market, they come with the need for the voice capability. A very easy example is the Apple Watch. Started as a data-only device, but then later on, voice was added as a capability to the Apple Watch for a number of reasons. Not only the ability to support voice calls and all of that, but one of the major features from Apple Watch nowadays is the ability to detect a need for a call to the emergency services and then to establish that call. And that's always done through the voice layer, let's say, it's through the voice capability and not the data capability. So again, all of the devices or most of the devices people use are smartphones, and there are still phones that require a phone capability. And we don't want to build a network that's not voice capable, because it would just eliminate a whole bunch of devices and use cases that we want to support. So supporting voice is very complicated, and that's why most of the MNOs and new operators try to come as a data-only service or offering. But that's really, from our point of view, limiting in many ways, and we want to make sure that we support voice, and for that we have to do a bunch of things that are very heavy in terms of engineering and then in terms of operations as well, because voice is very sensitive to end-to-end capabilities. And when I mean end-to-end, it's through the chip of the smartphone or the device, from the radio to the core network, and then to wherever the voice is being terminated. And all of these have to be super optimized, and literally, like, everything has to work almost perfectly. There's really not much room for minimal failure there. And making sure that happens, it's very, very complicated. You have to have a really good network. You have to test really properly and adjust the right parameters and all of that, and then monitor. Make sure, as we mentioned, that we not only monitor, but then we can act very swiftly, and that we have a very agile ecosystem that we can work on once we detect a need for a change. And yeah, so it's a lot of work, but we still feel that it's something super important for the foreseeable future.
Voice sounds quite tricky. How about SMS and E911? How are those services to add in to the capability?
So yeah, they ride on top of the data and voice services, actually both of them. And they require some very specific, again, capabilities from the chipset to the device itself, to the radio, to the core network, and then specific integration with the partners, because that call, E911 call, needs to go to somewhere, and usually, obviously, that's to specific points that address those calls. And then those calls are not simple calls. They actually have some metadata to make sure that the emergency services can act as quickly as possible, so they are effective as possible. So there's a layer on top of everything else that we discussed to be able to support that the federal regulation about emergency services calling service.
All right. One last question for you. You talked about interconnections earlier across the network and between radio to radio. How about between different providers and different partners? What is it sort of involved in sort of that bilateral interconnection and roaming capability?
So I find, so I work in this industry for quite a while, and I find it's actually pretty impressive that you can, with your phone, just literally roam across the world and have it working almost wherever you go. And that's basically a result of years and years and years of technology development, but then also in terms of network integrations. So that you can do that, networks had to integrate with each other. And integrating hundreds and thousands of networks between each other, it's very, very complicated. Actually, integrating any system between, and in this type of volumes, it's complicated. But then, this amount of networks and enterprises across several countries and different languages, and all of currencies and all of that, it's actually a very, very impressive to me achievement that we have made as an industry and as a whole. But and the only way that this works is that there are actually a set of standards so that each network has to follow. And that's why you don't get, for instance, when you get 4G only in your country, but you don't get 4G when roaming, and that same thing with 5G, and then the same thing is because these standards are still, kind of being implemented by the operators and optimized between them, and that's why it's not instant, right? And for us, so to be able to interoperate with all of these different partners, we have to be following those, implementing and following those standards, and making sure that whenever we are ready to be integrated with them and someone considers us ready, that we pass all the tests, not only in terms of functionality, but then also in terms of how to operate on a business level. It's fundamental in this environment.
Wow. Sounds like a lot of magic to make that seamless and transparent to the user. Excellent.
Yeah.
It's also very important to understand the years of work that most operators have put into establishing roaming relationships between themselves, because usually for you to accumulate like 300, 400 partners across the globe, you go through a lot of testing with each one of these partners, and it takes years for you to build such a footprint. So usually it's a very valuable thing for an operator to have hundreds of available roaming partnerships. And then sometimes they even use that to monetize with other kinds of agreements that they can do between themselves, like roaming sponsorships and such things.
Yeah, Miguel was leading on this front on our previous job, and he knows that if an operator, for instance, doesn't pass one test, and you just go back to that queue, and then it takes maybe days, maybe weeks, maybe even years in some cases, right? Where we get the next opportunity and slot to pass those interoperability tests, because the pipelines for these operators are huge, and they pretty much treat everyone equally in that sense.
Wow. Well, I'm gonna build on that, Miguel. So, working with MNOs, mobile network operators, sounds like there's a lot going on there. Can you talk a little bit, sort of, just about what it takes to run operations and to keep an MNO happy?
Usually, when you're talking about roaming in other networks, one thing that we usually have to understand first off is that operators don't tend to pay a lot of attention to roamers in their own networks, because they are used to a model where roamers come and go. So they come, they spend some money, and then they go away. And they don't pay a lot of attention to day-to-day operational issues. So it's kind of difficult to operate through these roamers, and you really have to know the way and who to talk with and how to work with different operators, because they also have different cultures from different countries. And you kind of have to know how to talk with each of these operators to make sure that they first pay attention to the issue that you are reporting to them, and second, that they actually fix that issue and don't just ignore it. Are actually the things that we like to monitor when you have a lot of people roaming around. is that you pay more attention to the quality of service that your roamers have in other countries than actually they pay to their own customers. So it's not untypical that you actually detect issues in the visited network that the home network hasn't yet detected from the
And this is going to be super important for us, of course, because XNet is going to start out like this foreign network. The quality of this network is going to be incredibly important, because if AT&T, T-Mobile, Verizon here in the US, or Orange, Rogers, Safaricom, whatever, if those customers don't have a great experience on XNet, then it's going to be a problem because of course our money flows in initially from those roamers, not so much from native XNet subscribers. But Miguel, I think people probably don't have any idea about the complexity of running like the network operations center and just the level of like engineering support it takes to do this well. Can you speak to what's required and what level of complexity and effort is to really kind of make these network operations work?
Yeah, so I think that when we're talking about network operations at the MNO scale, usually depending on the country size, you tend to have like thousands or hundreds of thousands of different cell towers spread across the country. Then you have all your core network sites with hundreds, if not thousands, of core network elements, and all of those things are generating events. They are producing data, and you will have to make sense of the information you're seeing. So the more context, the more information that event brings into the table, to the front of his eyes, the quicker you will be able to mitigate the issue. So the speed at which all of this data is collected, processed, enriched, and presented to a machine or to a human is essential to reduce the time it takes to resolve any given service issue or degradation. Yeah? So a lot of the value that these companies or the operators they produce to their customers, it's in their ability to ensure maximum service availability and to react as fast as possible to any service issues that may be detected. And for that to happen, they have to be able to detect them in the first place.
And we've seen a lot of companies doing something like they build a network and they build a NOC, and then the NOC is completely limited to point almost to being useless. It needs to come, cut deep through a whole integration, because if it's not done from scratch with the purpose of having the ability to operate that network, and if it's something that just comes later, you will not have the ability to develop the right tools, to have the visibility, and to have the impact when something needs to change or needs to be fixed, to be able to do that efficiently and effectively. So it cannot come as an accident or as a post-thought. It needs to come from scratch. We have the experience of actually seeing networks on large operators before they were even aware. So we were reporting them problems in a specific region or area, and we were reporting them, and they said, "Oh, we don't have an issue." And then, minutes or hours later, they would actually provide a report saying that they had an impact on a specific area. And that's the result of actually a lot of knowledge on how these things operate, but then also the ability to execute on making sure that the systems are thought not only to provide functionality, but they can be easily operated and orchestrated, and that they can be useful not only for the end customers, but also for the engineers and for everyone else in the organization.
All right, that's been fantastic, Miguel and Igor. Thanks for the great deep dive and the technical explanation. Rich, now that everyone knows a little bit more about kind of the technical back end of what's needed in order to actually build XNet, what's next?
Hopefully this has given our viewers some notion about what's really involved in building a true mobile network. And there's just so much to it, but monitoring it and keeping it running and making sure the experience is great for everybody. XNet is not just simply putting up a bunch of data access points and hoping people have access to cat videos. We're really trying to put together the whole package here. And by delivering that whole package, that's why the value of this network is between 5 and 10 times greater for mobile network partners who are going to work with us, because they're going to recognize the value and strength of this team. They're going to understand that we've invested deeply in the quality of the network, not just at the level of, have we deployed stuff, but are we monitoring it? Are there a combination of automated and human systems, if you will, making sure that everything is going well? If there's a problem, is that problem responded to quickly? we're going to be able to get top dollar in these mutual roaming relationships that we're negotiating. And so I think that's the really critical thing. We're not just building, again, a data network, we're building a true neutral host mobile network that'll interoperate with everyone, will provide great value, we think, to everyone. And it has a really high monetary value. And because at XNET, we're committed to taking, every dollar we get, every dollar of data roaming deal we get, 40 cents of that go right back into the hands of the folks who are operating and validating our nodes, right? Because we take that 40 cents, we buy our tokens off the market. We're going to return that value. We're sharing that value back with our founders, with our partners, with the people who are helping us operate our network. So anyway, this has been awesome, folks. We've got a lot more, stuff to cover. We can't cover it all in this session, but I'm really looking forward to the next edition of our conversation. Thank you, everybody, for watching. Thank you, everyone, for supporting XNET, and we will catch you again soon.